Friction is a force that tries to prevent two surfaces from sliding relative to one another. There are two main types of friction, which are the static friction and kinetic friction. Static means lacking movement, action, or change. Therefore, static friction is when the two surfaces causing the friction are not moving relative to one another. The word kinetic means of relating to or resulting from motion. Hence, kinetic friction is when the two surfaces causing the friction are moving relative to one another. Here we can see the formula for static friction, which is Fs equals to Fn, the normal force, times μs, the coefficient of static friction. And here the formula of kinetic friction, which is Fk equals to Fn, the normal force, times μk, the coefficient of kinetic friction. And here we can see the coefficient of static friction is typically larger than the coefficient of kinetic friction. This plot illustrates the standard model of friction. The two regions that we will be focusing on are the static region and the kinetic region. In the static region, the static friction will increase along with the increase in applied force until it reaches the maximum value of static friction. Once we surpass this point with an increasing value of applied force, the object is said to break free, enabling it to move or slide. This one. So, to keep the object sliding, we still need to apply force, and this is the kinetic friction. We can see that the value of kinetic friction remains constant as we do not need to apply as much force to keep the object sliding as we needed to originally break free of static friction. Here, we are going to look at simple experiments with a circular object on two different inclined surfaces. For both surfaces, we are going to look at what angle is required in order for the object to slide. So let's look at the smooth surface first, which is a book. As we can see, the circular object starts to slide when the inclined angle equals to 22 degrees. Now, let's look at the rough surface, which is the chopping board. As we can see, the circular object starts to slide when the inclined angle equals to 37 degrees. Thus, we can say that rough surface has more friction than smooth surface. Hence, larger inclined angle is needed for the object to slide down. This is a free body diagram of the previous experimental setup. We have normal force acting perpendicular to the surface and the weight mg that acts in the downward direction. The weight will then be resolved into two components, which are mg sin theta parallel to the inclined surface and mg cos theta perpendicular to the inclined surface. There is also frictional force parallel to the surface but opposite in direction of the resolved force mg sin theta. So, an increase in angle causes the value of mg sin theta to increase until it exceeds the value of the opposing static friction, resulting in movement of the object. This movement is now only opposed by the kinetic friction.